Hello and hi everyone. Today's video, we are going to present on the review on case study of design principle and application of geosynthetic, performance of geosynthetic cementitious composite mat GCCM in soil erosion. I will first introduce my group member. First member is Siti Rehana binti Nur Zentan. Second member is me myself Siti Suhaili binti Atan. And third member is Nurul Alfira Salama binti Mat Idris. These are the content that we are going to present in this video, which is the first content is introduction, followed by study case. Next is material and application, also methodology, and result and discussion, and lastly conclusion. The first content that we are going to present is introduction. As you guys know, soil erosion could cause landslide. And soil erosion also happen due to rainfall. Therefore, understanding on how different covers affect soil erosion is very necessary. Soil erosion also impacted by land degradation, cumulative watershed effect, change of soil function, also decrease of number of plant growths due to developing housing area on hill slope. Many techniques that has been introduced to solve soil erosion problems, such as bioengineering using vegetation, shotcrete application, and also geosynthetic. However, using synthetic manufactured material as land cover are more reliable alternative because of the limitation that the previous technique has. Geosynthetic cementitious composite mat (GCCM) is one of the geosynthetic products that has been introduced. GCCM introduced for slope stabilization and slope erosion protection application. GCCM gives displacement equalization and applying a frictional force and normal force to the slope surface to stabilize the slope. ASTM D8173 in 2008 is the standard guideline and requirement for site preparation, layout installation, and hydration of GCCMs. For this project, we have covered two case studies which focusing on the geosynthetic cementitious composite mat GCCM and also slope and embankment soil erosion. The first case study was by Sachet Liquid Le Swang in 2020. The research purpose is to investigate the performance of various land covers for soil erodibility protection based on a full-scale field test in Chakkhaoso province to the east of Bangkok, Thailand. The second case study was by Pika Jogvivatsakui in 2018, which the research aim is to focus on geotechnical engineering application. Experimental studies include physical and mechanical properties investigation of GCCM under installation and loading condition. This research is a laboratory test.
Hello, my name is Nurul Alfira Salama binti Mat Idris. I will explain about the material application and also methodology. For the material and application, for the first case study, it studied the performance of geosynthetic cementitious composite mat and vertigo on soil erosion control. Material durability and degradation over time need to be considered during the geotextile installation because geotextile need a resilient to the sunlight and water while supporting the vegetation growth. Universal loss equation USLE can be used to determine the soil loss from the overland flow. Vegetation is used by dissipating raindrop energy and increasing surface roughness to reduce the surface runoff velocity to reduce soil erosion. Next, for the second study case, it's do a research on experimental investigation on mechanical properties of geosynthetic cementitious composite mat, or known as GCCM. The GCCM was comprised of two layer of fabric, which is a woven and non-woven geotextile. As we can see from the slide, it shows the cement powder layer bounded with needle punching. The cement powder is firstly placed on the bottom woven geotextile layer and then sliced off until reaching the thickness of 10 mm. Then the top of non-woven geotextile was placed on the top cement layer before punching by hot needle, which operate by rolling machine. For the methodology, for the first study case, as we can see from the slide, it shows the embankment was constructed using a well-graded sand with approximately 45 degrees side slope. It's divided into the 6 study area, which is 3 different sized bare soil areas, 1 vegetation covered area, 1 GCCM covered area, and 1 particularly covered and vegetation covered by vegetation and GCCM. 3 area of bare soil, which is for the first, the area is 2.5 meter times 1 meter. For the second, 2.5 meter times 2 meter, and for the third, 2.5 meter times 4 meter are used to differentiate effect of the soil erosion based on the scale. After the GCCM installation, the GCCM was separate with the water for 3 days to treat the cement paste within. Soil moisture sensor was installed at a 15 cm, 30 cm, and 45 cm depth below the surface of the embankment. 100 liter containers were installed at the top of the slope for collecting the soil loss. During the storm period, surface runoff together with soil erosion were collected in the container through the gutters and the pipeline, and the soil will settle in the container before the oven dried, then it weighed. Next, for the second study case, for the methodology, the dried GCCM were prepared and weighed to determine the water per cement ratio, which is W divided by C. Then the water was measured and sprayed on the GCCM at 0.25, 0.50, 0.75 and 1 respectively. After a few minutes, to ensure that all the water was absorbed, the wet GCCM were weighed. Next, the non-moving and moving geotextile were gently taken off in the container and they were weighed. However, some cement paste may still remain within the geotextile. After that, all components were oven dried for 24 hours. After oven drying, the cement paste remaining within the geotextile was simply removed. The oven dried geotextile and the cement removed from geotextile were weighed separately. That's all from me. Thank you.
Hi and very good day. My name is Siti Rahana binti Nur Zintan. I will proceed to result and discussion. According to sub-study in year 2020, it found that geosynthetic cementitious composite map was more effective than vetiver grass and combinations of GCCM and vetiver grass. Based on PICHA study in year 2018, the finding found that geosynthetic cementitious composite map provide sufficient strength and can be used for reinforcement, protections of soil slope, and erosion control. Based on such study, this is the graph for soil loss. This is the graph for amount of soil loss under rainfalls on the test embankment. The black color represents of bare soil. The blue color represents of vetiver grass. The purple color represents of GCCM, and the yellow color represents of combinations of GCCM and vetiver grass. The vetiver show a high degree of erosion protections in the long term, which GCCM was more effective in prevention of soil erosion. The combinations of GCCM and vetiver grass slightly less effective in prevention of soil erosion, but effective for preserving soil compactions during rainfall and storm. Based on PICHA study, these are the graph for compressive strength and thickness of GCCM. The compressive strength increased with time and was 55 megapascal after 3-day curings, which is higher than normal concrete. The compressive strength of GCCM is 74.87 megapascal, which is higher than the requirement for structural shotcrete, which is 28 megapascal. The thickness of geosynthetic cementitious composite mat was constant at 8.1 mm. In conclusion, it established a theoretical basis to understand real and natural phenomena is incredibly challenging. In practice, geosynthetic cementation's composite net is formed in dimensions 1 meter of width and 3 meter of length, and also the weights of 30 kilogram. Since the product is manufactured uniform in factory, the properties of GCCMs are uniform compared to the product installed in the field. That's all from me. Thank you.